All right, welcome back again. We are dealing today with the second part of section 1.4. We're going to be isolating some variables. You're like, okay, solving equations is interesting enough sometimes. Why are we going to do all this with all these variables? Because as you can see here, sometimes we're going to have issues where we have an equation that we need to solve, a formula that we need a different part. Okay, just for instance, before we kind of jump around to some different ones. For instance, here, you may have seen this one before. I equals PRT is the interest formula. Well, what if I need to find out not what the interest is going to be, but what rate am I going to be receiving? Or how much time does it take for me to earn as much interest as I would like? Or when we're graphing, if I want something in slope-intercept form where I want y by itself. Okay, so there's some situations where it really is going to make a difference for us when we're trying to isolate. But the good thing is we use all the same rules that we do when we're solving equations. It's just now we're going to end up with variables on both sides. So let's jump in and give this a shot. Okay, first thing I would suggest with these, whenever you're told what variable you're solving for, immediately box that in. Colors even better, but at least box it in. Why? Because now my focus becomes, what do I have to do to get that variable alone? Well, here I'm adding 7x to it. So I need to minus 7x. And here's where caution comes into play. We just got done in a recent lesson talking about like terms. Okay? Are these like terms? No, this has x and this doesn't. So I can't do 8 minus 7 and call this 1x because they're not the same. So what do? Typically what I do is I'm going to go ahead, excuse me for a second here. There we go. I would go ahead and write it this way. Why? Because this is probably going to be something I'm solving for slope-intercept. Is it wrong when I see it written this way if I write this? Mathematically speaking, no, it's the same thing. But if, again, depending on what I'm solving for, if I'm trying to get into slope-intercept form, I want the x first. So I have to pay attention to this a little bit. Because if I had this and I was trying to graph it, I could mix up my slope and my y-intercept, and I don't want that to happen to you. But either one, mathematically speaking, would be correct, and that's it. Okay, 2, our interest formula. Okay, we're solving for t, so just the t I want boxed in there. And again, the question is, what am I trying to do to t? Well, I'm multiplying it by p and I'm multiplying it by r. So what's the opposite of multiplying? Dividing. And we can do both of those things at once. We don't have to do them separately. If we divide by pr, that gets rid of those. So I over, or divided by PR equals T. T's alone. We're good to go. That's going to be the main thing that we're working on with these. It's just making sure when we're doing this that we get that variable alone, we keep our rules. Okay? Here, solve for x. What's on the side with x that needs to go away? Minus 9y. What's the opposite? Plus. And as we said before when we were doing equation solving, if you're doing these steps and you can, cut the middle piece out and get to here, I don't care, but I still think it's better for you, for your long-term memory, when you think about it, maybe even speak it and write it, it tends to stay in your memory longer. So just a suggestion. Uh-oh. We've got a dying pen here. All right. And backup pen coming up. 9y minus 4. And another thing to keep in mind is if you happen to do it, let's say on the first one, like I had here, okay, and you're looking at my answer key later and you're like, oh, it's wrong. Just watch for your signs too. Oh, the 8's positive. The 7x is negative. They're the same because your answers can be correct and not necessarily look identical. So now I'm here. Am I done? Not so much. Because I'm still multiplying x by 11. And I've got to divide. Now when it comes to this, oops, what variable are you solving for, Hardy? X. Again, I don't mind if you keep it in a fraction form like this. We're going to get you some flexibility. That's going to be one of our main themes in here this year is doing the flexibility. Okay, so now I'm going to change up a little bit. Actually, I'm going to switch order for a second. I'm going to jump down to number 6. I will come back. There's a method to the Hardy madness here. Okay, so this time we're solving for b. So now how do I know if I should deal with the minus 3a or the divide by 5 first? And it's an important question. Whenever you see plus or minus with a term, that's got the strongest, the closest bond. And it's going to be the hardest one to break. So we got to wait on that one. Whenever there's a fraction or division involved, we probably want to deal with that first. So what we're going to do is we're going to do the opposite of divide by 5. And we're going to multiply by 5. Get that fraction up out of there. Okay, once we do that, now, same thing we were doing before. The goal is get b alone. Okay, what do I do? The opposite of this. What's the opposite of that? Subtract it. And again, just for reference, we normally will put terms with variables before we put the constant term. But if you put 20 minus 3a, perfectly acceptable. So now, the last couple to take a look at up in this section are the ones that tend to drive people the craziest. So this is why we're going to lock in on a couple of them. Okay, solve for y. You're like, wait a minute, Hardy, there's 2 y's. Which y do I box in? Neither yet. We need to get it down to 1 y somehow. You're like, huh? Okay, let's look at this for a second. Do these 2 terms have anything in common? Well, yeah, they both have a y. Okay. So when that happens, I can take a y out, whatever they have in common. And then the question becomes, okay, what would I multiply y by to get x times y? Well, I already have the y, so I need an x. What would I multiply y by to get negative y? Now, this one might be a little trickier. Just want to change the sign. We do negative 1. You're like, wait, now how'd you just get away with that? Well, let's think about it for a second. If this were to be there and I said simplify, and you would distribute, what would you end up with? X times y, and y times negative 1 is negative 1y, or xy minus y. Same exact thing. It's just in a different format. And that format in this case is really important to us because now there's only one y. The one that I want to get by itself, the one that I want to solve for. So now the question becomes, don't distribute it back out, we'll end up back here. What does it mean when you have something with parentheses next to it? We're multiplying. So to undo multiplying by this quantity, by this set of parentheses, x minus 1, we just divide by it. That goes away. And we're good to go. Okay? So the first couple of times you see this, probably going to want this handy just to get you thinking about that. But even better, we're going to do another one right off the bat just to make sure that we get you set. Okay. Now this one, there's one extra step. Okay, we're going to solve for a. Oh, there's a in 2 places, Hardy. Okay. First job, we want them all together. Since this side only has a term with an a, we're going to take that positive 5a, we're going to move it over with that. Now again, I could have moved ab over here, it just would have been a little more work, so I decided to avoid that. Now, my a terms are on the same side of the parentheses, they need to be, because in this case, a can't be part of my answer. Or back in number 4. The variable you're solving for can't be part of your answer. So I can't have y equals and have y over here. And when I'm doing number 5, when I solve for a, I can't have a in my answer either. There's just something else to ponder. But now I got an example to work with here. I'm like, okay, now what do I do? Oh yeah, these both have A. So I take what they have in common out, take the A out. So now, A to get to AB. Well, I already got the A. I need the B. A to get to negative 5A. I've already got the A. I need the negative 5. Same thing, but now I've got my target in sight. There's only one A, and that's the one I want to get alone. So I go ahead and divide out by that B minus 5. Those all go away. A is not in my answer. Most important thing, your variable can never be part of your answer that you're solving for. And I'm set. Okay? And this is going to give me a lot of flexibility when we're solving equations down the road, maybe, that have some multiple variables to play with, but especially slope-intercept form and formulas, which we're going to see more of here in the coming weeks. So one example to be able to put this to use here, and then we'll get you a little practice in on your own as well. Okay, the volume of a pyramid is found by using the formula, and this is the formula for volume. Okay? First, rewrite the formula by isolating for the height. Solve for h is basically what we're saying. So we're going to take that equation, we're going to solve for h. Now again, this is just me, just from experience, from seeing this for many years. I would get rid of the fraction first. I would not sit here and say, oh, divide by 1/3 LW, because I've noticed a lot of students don't understand what dividing by 1/3 means. Okay? So what we're going to do, when you're dividing something by 3, because just as a side note here, dividing by 3 is the same thing as multiplying by 1/3. Okay? So if I'm taking all these things right now and dividing by 3, what's the opposite of divide by 3? Multiply. So we're going to multiply both sides by 3 just to get rid of the fraction on the right side. Just to keep life simpler. Because I don't know about you, but that looks a lot easier to deal with me than having that fraction there. Just saying. Because now, okay, I'm solving for h. What's being done to h? I'm multiplying it by L and W. What's the opposite of multiplying by L and W? Dividing by L and W. So 3V divided by LW equals h. So if I just wanted to find the height and I knew the volume, the length, and the width, I could do that. And that gets hard because you're like, oh my gosh, there's variables everywhere. What am I? Stay locked in what you're solving for. And that's why I keep saying box it in so your focus stays there. Because otherwise it's really easy to kind of get into a panic and get frazzled about it. Now, find the height of the pyramid. Thankfully, we have it solved for h now. This is going to be a lot easier. With a volume of 240. So replace the V with 240, a length of 10, and a width of 9. And now we just go to the calculator. And again, I always tell people, either you need to use the parentheses or just do your numerator, then do your denominator, then divide the answers. So if I punch this into my calculator, 3 times 240, okay, that's going to be 720. If I type 10 times 9 into my calculator, that's 90. And then go ahead and divide. And find my height. Okay? Not too bad. It's weird. I admit it. I'm not going to tell you it's not. But try it out. Okay? See how it's going. If you notice, we gave you a couple of options here. Okay? Isolating variables practice. I'm going to warn you on something back here. When you're going through doing these, purposefully, there were a couple of challenge problems put in. Okay? 4, 5, and 6 are going to give you a challenge. And I want to make one note here at the top for those of you that are up to the challenge. We all know that add and subtract are opposites. Okay? When we're doing this solving. We all know that multiply and divide are opposites. Okay, we do that a lot when we're solving. There's going to be a couple in here that are going to challenge you a bit because there's squareds and square roots. So doing squared and square root are opposites. If you get to the end and you have an x squared you're solving for, you take the square root. You'll get it to x. If you have a square root, you square it. It gets rid of the radical. Am I going to jump in on one of these? They're like, Hardy, if you want us to do them, you better. Okay, I'll jump in on one. Let's do 6. 6 seems like it's a little bit more out there than the rest. Okay, we're solving for x. Now, x is stuck here in radical jail. So this one's a little bit different. My first job is I got to get the radical alone. I got to get things out of the radical first. So what do I got to do? What's not in the box? -4. Do the opposite. So, okay. Now again, my goal is still to get to the x, but the x, again, is stuck in radical jail. We have to undo that. How do we do that again? Opposite of square root is squaring something. So, we're going to square both sides. So on the left, all that squared is going to do is cancel out the radical. It does nothing to what's underneath. That gets left alone. On the right side, don't worry about multiplying this out. Don't distribute the squared. Don't do anything. Keep it simple right now. Okay, y plus 4 squared. Perfectly good. But now we see the light at the end of the tunnel. Now this is starting to look like it's going to be a little more normal. I want the 2x by itself. How do I get the 5 out of there? Okay, and that y plus 4 that's in parentheses, you cannot put the 5 in there. That cannot become 9. That is not how this works. You're like, oof, are we almost there? We are. Because now to get x alone, I have one step left. It's the opposite of multiply by 2. Divide. All of that for x. Yep. Okay. So again, 4 and 5 are going to be similar in that, well, you're going to be using square root instead. But give them a shot, okay? Or at least give a couple of them a shot. Give a few a shot. On any of these assignments, I always say, if you're kind of iffy on if you're going to get through, always start with the evens. And then if you're going good, okay. And if not, go back and do some odds. And if you're really needing some more practice, especially with isolating y, we're getting ready for y equals mx plus b for slope-intercept form, I'd really make sure I locked in on most of these. Okay? Get ready to do that, because when you get to graphing, man, it's going to make it easier if you can get things into form quickly. Okay? So that's it for this one. Thanks again for hanging out with me, and we'll be seeing you soon for some more.